Any doubt, students? Okay, fine. Hoping that you people have understood this Wheatstone network. We will move to the next topic, that is meter bridge or slide wire bridge. Okay. So see, coming to the what do you mean by this meter bridge? I'll just read out that it is the simplest practical application of the Wheatstone bridge that is used to measure an unknown resistance. As I said, okay, you have an experiment, okay, that is to find the resistivity of a wire. Okay, to find the resistance of the wire, you are going to make use of the apparatus called as meter bridge, or we call that one as slide wire bridge. Okay, so you come across this in your practical. So why do we call this one as meter bridge or slide wire bridge? If you ask that, see, this bridge consists of scale of 1 meter. Okay, so you have a scale mounted on that bridge, so which is of 1 meter. So we call meter bridge, or we call that one as slide wire bridge. So in this apparatus itself, in this experiment itself, we are going to make use of this jockey. Okay, so jockey is a thing where we are going to slide it on a wire. Okay, so this meter bridge consists of a wire where we are going to slide the jockey on that wire. Okay, so since we slide the jockey on the wire, okay, we call this as also as slide wire bridge. Okay, and the main practical application of this is nothing but it works on the principle of Wheatstone network. This meter bridge works on the principle of Wheatstone network. Okay, and this is a Viva question also. In case if you get this resistance to find the resistivity of a wire, okay, experiment in your examination. So the definite question is nothing but they are going to ask on what principle this meter bridge works. You need to say that it works on the principle of Wheatstone network. Okay, so next, coming to this construction part, I'll come. Okay, I'll just read out that, just go through. It consists of 1 meter long manganese wire of uniform cross section stretched along a meter scale fixed over a wooden board with two L-shaped thick copper strips. Between these two copper strips, another copper strip is fixed so as to provide left and right gaps. A resistance box is connected to the left gap and the unknown resistance S is connected in the right gap. A source of EMF E and plug key K is connected across AC. A movable jockey and a galvanometer G are connected across BJ as shown in the figure. Okay, so here, let me explain the components, okay, or the apparatus of this experiment. So see here, as I said, you have a 1 meter scale, okay, which is between A and C. Okay, and you can see the orange color is nothing but it is a metal strips we have taken. So we have taken two L-shaped metal strips, okay, you can see there, and we have taken a small metal strip which is in a straight, okay, shape. So when it is placed, okay, it forms a left gap and right gap. Okay, so here I'll just show it. This is a L-shaped metal strip and this is also a L-shaped metal strip, and we have taken one more metal strip, okay, fixed at the center so that it provides the left gap and right gap. So this is the left gap and this is the right gap. Okay, so and A and C are the terminals, okay, and terminal A is connected to battery, okay, and terminal C is connected to plug key. From plug key it is connected to negative terminal of the cell. Okay, so next you can see there between B and J there, okay, J is the center of the scale, meter scale. Okay, so between that B and J we have connected the galvanometer. Okay, you can see the symbol of that galvanometer, that is the needle. Okay, that denotes the needle. Okay, so in the left gap we have connected the unknown in the left gap we have connected the which is it, a resistance box. Okay, In the left gap we have connected the resistance box, whereas in the right gap we have connected the unknown resistance. Okay, we don't know the value of that resistance which we have connected at the right gap. Okay, left gap we have connected the resistance box. Left side we have connected the resistance box, and the right side we have connected the unknown resistance. Okay, so next here what we are going to do is we are going to take a jockey. Okay, so what is the use of the jockey is nothing but when you slide, okay, from terminal A to terminal C, if you keep on sliding the jockey on the wire, okay, so the wire is mounted on the scale. Okay, that wire is made up of manganese. Okay, so when you slide the jockey on the wire which is directed towards A to C, so what happens, at some point the galvanometer reaches zero deflection. Okay, when the galvanometer reaches zero deflection, it is said that the bridge is balanced. Okay, so at that time what we are going to do is we are going to note down that value, at which value the galvanometer is reading zero deflection. Okay, so according to the figure they have said that between B and J it is galvanometer is connected. So from A to J it is considered as L, and from J to C it is considered as 100 minus L. Since you know that it is a 1 meter scale, so in terms of centimeter it is 100 centimeter, right? So from if you take from A to J, the length is, if you consider as L, so obviously from J to C it should be 100 minus L. Okay, so this is the explanation of the figure. Okay, next I'll read out how it works. Here I'll just read out that taking out a suitable resistance R from the resistance box, the jockey is moved along the wire AC. Let the position of the jockey be at J such that galvanometer shows no deflection. Let the resistance of the wire between A and J be P, and the resistance of the wire between C and J be Q. If rho is the resistance per unit length of the wire, then okay. So here, as you know that we have taken the resistance box, we have connected the resistance box on the left side, that is R denotes the resistance box and S denotes the unknown resistance. Okay, so in the resistance box what we are going to do is we are going to unplug some resistance. Okay, so next what we are going to do, we are going to slide the jockey on the wire. Okay, so it is considered that, or it is assumed that, let at J, let at point J the galvanometer reads zero deflection. Okay, assuming that at when you are sliding the jockey from A to C, at point J the galvanometer reads zero deflection, that means that the bridge is balanced. So that what we are going to do is between this A and J, okay, between this A and J what we are going to do is we are going to consider the resistance between this A and J as P. Okay, the resistance between A and J is considered as to be P. Okay, from here to here it is considered as P. Next from which is that J to C, the resistance is considered to be as Q. Okay, so from C and J the resistance is considered to be as Q. So now, since if rho is the resistance per unit length of the wire, okay, as you know that R is nothing but what is the mean difference between this resistance and resistivity. I have made it clear long back itself. Resistance is nothing but we are going to define that one as just simply the resistance offered by the conductor, right? So when I am talking about the resistivity, I need to mention the length and area of cross section. Okay, so obviously what we have taken, the length of the meters, I mean the scale what we have taken is 1 meter, so obviously it should be uh, per unit length, right? The resistance should be nothing but per unit length, that is rho. Rho is the resistivity. Resistivity is nothing but resistance per unit length, right? Rho denotes the resistance per unit length. So next what we are going to do is, let us take this P is equal to rho into L. Okay, so this P is equal to rho into L. Next, Q should be nothing but equal to rho into 100 minus L, because see here P is nothing but what, it is the value between A and J. Okay, so hence that can be written as P is equal to rho into L here. So next, between this C and J, the Q value, Q is the resistance, so that can be written as rho into 100 minus L, correct? So that is the thing there. Next, what we are going to do is, as we know that since resistance of the wire is directly proportional to the length of the wire, so this we have read, right? So resistance of the wire is directly proportional, resistance is directly proportional to the length of the wire, right? According to that, we have written here P is equal to rho into L and Q is equal to rho into 100 minus L. Okay. Next, according to the principle of balanced Wheatstone bridge, what is that principle? This is the thing. P by Q is equal to R by S is the principle of balanced Wheatstone bridge. So now, what is our agenda? Our agenda is to calculate the value of S. Okay, to calculate the resistance of the unknown wire which we have placed between the right gap there. So now, taking S on the left hand side, S is equal to Q by P into R. That is a mathematics. Okay, P by Q is equal to R by S, right? So S is nothing but equal to Q by P into R. So now we know that the value of Q and P. Substitute the values. So S comes out to be as rho into 100 minus L divided by rho into L. So rho and rho get cancelled out. The left out thing is S is equal to 100 minus L divided by L into R. Okay. So see here, how we are going to consider, how we are going to find the value of S is nothing but, see, R is what? This is nothing but the resistance which is unplugged in the resistance box. Okay, so when you plug the resistance in the resistance box, it will be given, the values will be given there itself. Okay, so if I consider the, if I unplug the resistance of 5, okay, while taking the reading, so that is a known thing, R value is already known. Okay, since we are we itself unplugging the resistance in the resistance box, so the R value will be known to us. Next is nothing but what? 100 minus L divided by L. What is this L value? L value is nothing but where the galvanometer reads 0 deflection. Okay, let us say that the meter bridge starts from 0 to 100, right? Okay, let us say that at the 60 centimeter the galvanometer reads 0 deflection. So the value of L comes out to be as 60 there. If you substitute the value of L as 60, so the equation, in this equation, S is equal to 100 minus 60 divided by 60 into R. So by this uh, way you can find out the value of S. Okay, so in this experiment, once you do the experiment, you will come to know. Okay, so we are going to take a average. Okay, that means that we are going to take 3 to 4 values, so that the average value of that is considered as the value of the unknown resistor. Okay, this is how, by making use of the meter bridge, we are going to calculate the value of an unknown resistor. Okay, so they have given that the last two lines, I'll read out, see there. Thus, by knowing the values of L and R, we can calculate the unknown resistance S can be determined. Okay, that is what I said. So L value will be knowing, and R also we will be knowing. By making use of that, we can easily find the value of S. Okay, so do one thing, just go through this for a few minutes. So in case any doubts, please do ask. Okay, so just go through. Okay, students, any doubts? In case if you have any doubts, please get it clarified. Okay, Meghana, no doubts. How about others? Have you understood? Shall we move to the next topic? Okay, fine. Okay, fine, students. So see here, next coming to this potentiometer. Okay, so see here, potentiometer is a device. Okay, so it is a device which is used to measure an unknown EMF or potential difference. Okay, so see here, the main uses of this potentiometer is nothing but the device which is used to measure an unknown EMF. I think you are aware of this EMF, right? Electromotive force or the potential difference. See, actually it's a little bit printing mistake there, typing mistake. Okay, so it should be a potential difference. Okay, so it should be a potential difference. So what do you mean by this potential difference? Potential difference is nothing but it is a voltage drop. We also call that one as voltage drop. Okay, so potentiometer is a device which is used to measure the EMF, unknown EMF, or to measure the potential difference accurately. See, in even this experiment you have in your practical examination. Okay, so we are going to make use of this potentiometer. One is to find the internal resistance of the cell. Okay, the application of this potentiometer is also one more thing is nothing but to find the resistance of an cell, internal resistance of the cell. Okay, you have that in your practical examination. The second one is nothing but to find the to compare the ratios of EMF of the two cells, to compare the ratios of uh, the two cells. Okay, ratios of EMFs of two cells. So two experiments you have by making use of this potentiometer. Okay, so see here, the most common question which is used, I mean which is asked, okay, in your practical examination, whenever you get this to find the internal resistance of the cell and to find the ratios of the EMFs of the two cells, the most question, the frequent question which is asked is nothing but what is the use of this potentiometer. They are going to ask. You need to say that the first one is to find the internal resistance, next to find the EMF, okay, or the ratios of the EMF of the two cells, or to measure the voltage or the potential difference across the 2 points you need to say. Okay, and one more question they are going to ask is which is the device which measures the potential difference accurately. Okay, see, there are two devices which we are going to make use to calculate the to find the potential difference. One is nothing but voltmeter. Okay, voltmeter uses to always measure the voltage between the 2 points or the potential difference between the 2 points. Okay, so voltmeter also we are going to use, potentiometer also we are going to use. Okay, in that they are going to use, I mean in that they are going to ask one more thing is which is the device, okay, between this voltmeter and potentiometer gives the accurate value. Okay, which gives the accurate value they are going to ask. You need to say that potentiometer is a device which gives the accurate value, which measures the accurate potential difference between the 2 points. You need to say, they are going to ask why is that. Next question they are going to ask, you need to say that when you connect the voltmeter, okay, to find the potential difference across any 2 points, the voltmeter draws some current from the circuit. Okay, it draws the current, some amount of current from the circuit, and it shows the voltage. Okay, so which is not the accurate value which the voltmeter is going to show. But when you connect the potentiometer doesn't draws any current from the circuit. Okay, it doesn't draws the any current from the circuit. Hence the value which is shown by the potentiometer is the accurate value. Okay, so hence when you compare this voltmeter and this potentiometer, in order to calculate the potential difference across any 2 points, so the potentiometer is the one which gives the accurate value. Okay, so this is the viva questions. Okay, in case if you get the potentiometer experiment in your examination. Okay, first question is nothing but they are going to ask what is the application of this potentiometer. Next is which is the device we are going to make use to find the potential difference. You need to say voltmeter and potentiometer. Next is nothing but which compared to this voltmeter and potentiometer, which is the device which gives the more accurate value they are going to ask. You need to say potentiometer. Next question is nothing but they are going to ask why. You need to say that voltmeter draws some current from the circuit, whereas the potentiometer doesn't draws any current from the circuit. So hence the value which is shown by the potentiometer is accurate. Okay, so that is the thing. Okay, so next here I'll come to the construction of this potentiometer. See, let us see what is this potentiometer consists of. A potentiometer consists of a very long wire AB of uniform cross section, usually 1 meter long, of material such as constantan or manganese. The wire is fixed on a wooden board and joined by a thick copper strips. A meter scale is fixed parallel to the wires. The ends A and B are connected to a strong battery, a plug key, and a rheostat. This circuit, called driving or auxiliary circuit, sends a constant current I through the wire AB. Thus, the potential gradually falls from A to B. A jockey can slide along the length of the wire. Okay, so here coming to this experimental setup. So this potentiometer, as you know that it consists of a 1 meter long wire. Okay, you have two types of potentiometer. Okay, the only difference between two is nothing but some of the potentiometer consists of 1 meter long wire, some of the potentiometer consists of 4 meter long wire. Okay, so as of now we are dealing with 1 meter long wire. Okay, so see here now, as I said, the potentiometer consists of 1 meter long wire. Okay, so which is mounted on the board. Okay, sorry, which is mounted on the scale, 1 meter scale. The wire is mounted on the scale. Okay, and that wire is made up of constantan or manganese. The material which is made up of the wire which is made up of material called as constantan or manganese. Okay, and this wire is mounted on the scale, 1 meter scale. Next, this wooden board, what they have given, you have a copper strips. Okay, this potentiometer consists of a copper strips. Okay, so next is nothing but, as you know that when you switch on, when you close the plug key, so what happens when you close the plug key, the current starts to flow in the circuit. As you know that you have a battery here. Okay, and you have a ammeter and you have a rheostat here. Okay, so ammeter is nothing but to adjust the value of the current in the circuit. Okay, so next, rheostat value is nothing but it is also used to, as I said, ammeter shows the value of the current which is flowing in the circuit, whereas a rheostat is nothing but which is used to adjust the value of the current in the circuit. So next we have connected the voltmeter. Okay, voltmeter is nothing but one end of the voltmeter is connected to terminal A and the another end of the voltmeter is connected to jockey. Okay, so jockey is nothing but which is used to slide the jockey slide on the wire, so that the point where to show the potential difference between any 2 points. Okay, whenever you slide the jockey on the wire, it shows the potential difference. Okay, let us say that the jockey, one end of the jockey is at J there. Okay, when you slide that jockey, okay, the A and J, between A and J, the voltmeter shows the potential difference. Okay, next here the principle of the potentiometer is nothing but, I'll just read out. Potentiometer works on the principle that when a constant current flows through a wire of uniform cross-sectional area, the potential drop across any length of the wire is directly proportional to that length. Okay, so here it is assumed that, let us say that a constant current flows through the wire. Okay, the wire, as I said, the scale is fixed between point A and point B. Okay, over that scale a wire is mounted. Okay, so whenever you close the plug key, what happens? The current starts to flow through the wire, through the circuit. So when you slide that jockey, so what happens when you move from terminal A to terminal B? So what happens? The length keeps on increasing, right? So at terminal A, let us say that the scale value is 0, and at terminal B the value of the length of the length is nothing but 100. Let us consider, since I have said that 1 meter scale is mounted. So when I slide the jockey from A to B, what happens? The length keeps on increasing. Okay, so the principle, what the principle of the potentiometer is nothing but it is said that when the constant current flows through the circuit, okay, so the length of the wire is directly proportional to the potential difference across the wire, they have said. Potential difference across the length of the wire, they have said. That means that as you keep on increasing the length, as you move away from the terminal A, point A, what happens? The length increases. Okay, as the length increases, what happens? The potential drop also increases. That can be recorded through that voltmeter, that is here. Okay, so let me make it clear. See here, let us say that I am sliding the jockey from terminal A moving towards terminal B. So let us say that at J I am going to stop. Okay, just I am going to read the voltmeter reading. Let us say that the voltmeter shows 2 volt. Okay, so next what I am going to do, just I'll slide the jockey towards B. So what happens? Let us say that I have kept the jockey here at this point. Okay, so the voltmeter, okay, the reading shown in the voltmeter will be more. In the previous case it was 2, let us say that now it is 3. What does it mean? The length has been increased, right? Okay, the length is increased. Similarly, the potential difference, the voltmeter reading is also more. That means that whenever the constant current flows through the circuit, the potential difference between any 2 points is directly proportional to the length of the wire we call. Okay, so the potential difference or the potential drop is one and the same. Okay, so if that is the case, see here, just I'll read, if the voltmeter is connected between A and J, it reads the potential difference. Yeah, that is what I said. Next here, by Ohm's law, as you know that Ohm's law is nothing but what I have said, V always denotes the potential drop, right? So V is equal to I into R, correct? So what I am going to do is I am going to take the value of R as rho L by A. Okay, rho L by A. Why is that? Since I have taken the length of the wire as 1 meter. Okay, rho denotes what? Resistance per unit length per unit area. Okay, so I have substituted the value of R as rho L by A. So hence it is said that for a wire of uniform cross section, resistivity rho and the area of cross section are constants. Therefore, when a steady current I flows through the wire, what happens? I rho divided by A is nothing but equal to 5 we call. See here, I'll just make it clear. See what happens, what I said, as you keep on moving the jockey towards the B, what happens? The length keeps on increases, right? As the length increases, what happens? The potential drop also increases. That is the principle. When is that? When the constant current flows through the wire. Okay, whenever the constant current flows through the circuit, so what happens? The potential difference across any 2 points is directly proportional to the length of the wire. Okay, that is the principle. Next, what they have taken is, by Ohm's law, by making use of Ohm's law, they have said that the known equation V is equal to I into R. What does it V denotes? V denotes the potential difference or potential drop. Okay, so according to that, V is equal to IR. R value we have taken as rho L by A. Okay, so what we have done is, for a uniform cross section of resistivity rho and the area of cross section, what we have done here is, what we have considered here is, the area of cross section of the wire is constant, and what is that? The current I value is also constant, right? So the next equation what we have written, V is equal to I into rho L by A, that can be written as I rho by A, that is nothing but equal to phi. So where phi is the potential drop per unit length of the potentiometer wire, known as potential gradient. Okay, so hence we are going to write this one as V is equal to phi into L, or that phi is nothing but what, it is a constant. So hence V can be written as V is directly proportional to I. Okay, so what is that V? V is nothing but potential difference across any 2 points, and I is nothing but the, sorry, and L is nothing but the length. So according to the principle, V is directly proportional to L. So this is the principle of the potentiometer. Okay, you do one thing. Anyhow, we have left out with only 2 minutes, 2 minutes I think. I have forwarded these notes in the group, right? Please go through about this potentiometer. Okay, so just go through the principle first, next go through the explanation. Okay, just go through, and in case if you have any doubts, please let me know in the next class. Okay, so anyhow, since we have left out with only 2 minutes, I'll just end up today's class. Okay, so in the next class I'll start with the potentiometer again itself. Okay, again I'll start with the potentiometer itself. In case if you have any doubts, you can get it clarified. Okay, before that, make sure that you have gone through once about this topic, potentiometer. Okay, uh, okay students, we will end up today's class. Just a minute, I'll take the attendance. Okay, fine. Thank you students.